4.1 Angles and their measures. Radian. A central angle of a circle has a measure 1 radian if it intercepts an arc with the same length as its radius. So kind of like this. So in this case, the radius equals the arc that it intercepts. To convert, degree radian conversion. To convert radians to degrees, multiply by this. To convert degrees to radians, multiply by this. So degrees and radians are just two different ways to measure an angle, and we're going to be using both of them in this class. Okay, arc length formula, and there should be a parentheses here. Radian measure. If theta, this is theta, is a central angle in a circle of radius r, and if theta is measured in degrees, then the length s of the intercepted arc is given by this equation. All right, the degree measure of this formula, if theta is a central angle, blah, 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 same thing. This is the formula. Now, distance conversions. This is an abbreviation for statute miles. A statute mile is basically like a regular mile, 5,280 feet, a land mile, if you will. This is an abbreviation of nautical miles. A nautical mile is the length of 1 minute of arc along the Earth's equator. So if you imagine the globe of the Earth, and then if you imagine a central angle that measures 1/60th of a degree, that intercepts an arc that is 1 nautical mile long. Okay, so these are conversions in between statute miles and nautical miles. All right, let's do some examples. Convert from decimal form to degrees, minutes, and seconds. Okay, the 47 is already in degrees. We just need to convert the 0.6 into minutes and seconds. The way you do that, we're going to multiply 0.6 times 60 minutes over 1 degree. And the reason for that is because 1 degree equals 60 minutes. Okay? So, if you put this into your calculator, you end up with 36 minutes. And because there is no decimal, we don't have to convert anything into seconds. If this was 36 point something, then you would have to convert further into seconds. But we've got 36 minutes, I'm going to put this here, and 0 seconds. Okay, convert the following degree measure to radian measure. All right, so for this one, what we're going to want to do is multiply 225 times pi over 180. And you're going to want to keep this in fraction form, okay? So if you do this, you'll end up with 5 pi over 4. And actually, let me show you a little trick with your calculators if you have trouble simplifying fractions. If you pull out your calculator and you were to divide 225 divided by 180, okay, you would get a decimal. But if I wanted this as a fraction, all you would have to do is hit math and then number 1 for fraction. And this will convert your answer into a fraction. Okay, so once again, math and it's the first one. There you go. Okay, convert from radians to degrees. Oh, by the way, this is what you would put in here. There we go. Convert from radians to degrees, so this time we're going to multiply by the reciprocal of that formula. So the pi's cancel out. 180 divided by 9 is 20 degrees. Okay, convert from radians to degrees. Now in this one, we're not going to get a nice answer. Okay, so what I'm going to do, let's see here. I'm going to multiply 11 times 180 over pi. Okay, now it says here, round to the nearest hundredth as needed. So we know we don't want things in terms of pi. So if you put this in your calculator, 11 times 180 divided by pi, and actually, it's a good idea, let's see here, 11 times 180. It's a good idea to get into a habit of using the pi button and not 3.14, because sometimes it won't give you an exact answer if you use 3.14. So I'm going to divide by second pi. Okay, so as much as possible, try to use the pi button. And that's what you get. So 630.25 degrees. Okay. Find the radian measure of the central angle of a circle of radius r equals 90 inches that intercepts an arc of length s equals 60 inches. Okay, so for this one, we're going to want to use that formula, s equals r theta. And then we just plug everything in. We've got s equals 60, r equals 90. So 60 equals 90 theta. Okay. Notice that they want a simplified fraction at the end. So if I divide both sides by 90, whoops, this cancels out. And I'm left with theta equals 2/3. Okay. All right. A central angle intercepts arcs S1 and S2 on two concentric circles with radii R1 and R2 respectively. Find the missing information. All right, so in this case, it actually helps to make a little bit of a diagram. Okay, so this isn't, hopefully you guys can see this okay. If you guys remember from geometry, concentric means two circles that have the same center. So basically, their circles are around the same center, but one is bigger than the other. So each circle has a radius. So the radius of the first circle would be this, and the radius of the second circle would be all the way from the center to the edge. Okay? And then the arcs, this would be S1 and this would be S2. So as you can see, S2 is going to be bigger than S1. Okay? But they both have the same central angle. So this is what I'm going to do. I'm going to use this formula for R1 and S1 to figure out what theta is, because I know that same theta can be used for R2 and S2. So I'm going to plug in 9 and 10. Okay, so theta equals 9/10. And now I'm going to use this when I do the same equation for my other arc and radius. So now I'm looking for S2, but I have my R. Oops. And I have my theta. So it looks like S equals 18. So theta is 9/10, and S is 18. That's what you would put here and here. Okay, a bicyclist races on a bicycle with 13-inch radius wheels. When she is traveling at a speed of 33 feet per second, how many revolutions per minute are her wheels making? Okay. First thing I want to do is I want to convert 33 feet per second into inches per minute. And I want to do that because I have the radius in inches and I'm looking for the revolutions per minute. So I've got 33 feet per second times 60 seconds per minute, because there are 60 seconds in a minute, times 12 inches per foot, because there are 12 inches in a foot. So I've got seconds on top and bottom, so those cancel out. I've got feet on top and bottom, so those cancel out. So at the end, I'm going to be left with inches per minute. And if you multiply this out, you end up with 23,760 inches per minute. All right, so now what I'm going to do is I'm going to find the circumference of the wheels on my bicycle. The formula for circumference is 2 pi r, and I know that the radius is 13, so I'm going to plug that in. So I've got 26 pi. So this is what's going on. The circumference, that's the distance around each wheel, is 26 pi. Okay? My bad, 26 pi inches. And I know that she is going 23,760 inches every minute. So what I can do is I can divide this by this, and I will get the revolutions per minute. And I get approximately, 290.89 revolutions per minute. So it's going all the way around this many times every minute. All right. Okay. A simple pulley with a given radius r used to lift heavy objects is positioned 20 feet above ground level. Given that the pulley rotates through an angle of theta, determine the height to which the object is lifted, assuming that the object starts from the ground. Complete parts A and B. Okay, so we need to solve these two things. Once again, we are going to be using one of those formulas. This time we're using this formula. And you know what? I just realized something. I'm going to scroll back up here. Forgot the R in here. So if you guys can make this correction, here, let me just rewrite it. This should be pi r theta over 180. My bad. There we go. Okay. Okay, so what I'm going to do is I'm going to plug these in. So for A, I'm going to plug in 4 and 540. And then you just solve. If you do this, you end up with 12 pi. So you write 12 pi inches down here. And then you do the same thing for part B. I'm going to write this down here. So S equals pi times 3 times 360 over 180. And if you do this out, you're going to end up with 6 pi. There we go. And that's all the notes for today.